Hey guys, how's it going? If you haven't watched me before, I'm Ferris. Welcome to not another episode of Ferris Makes Emulators, but I guess the first episode of Ferris Does Whatevs, where I'm just kind of streaming when I feel like it and doing whatever project I actually feel like. And today I'm working on a little project that is an Asteroids clone in Elm. Now, unfortunately, I'm not doing this from scratch. This is a project that I started on Wednesday, and I've made a fair bit of progress. And so, yeah, I just kind of want to bang on this and just kind of do my thing, and just I don't know, just kind of hang out instead of, yeah, I don't know. I just want this to be pretty chill. So yeah, let's just kind of get started. For those of you who are not familiar with Elm, oh wait, who is that? Lohenzo. Hey, how's it going? For those of you that are unfamiliar with Elm, it is a functional programming language. That's basically meant to bring something Haskell-like to front-end web coding. Now, normally I don't really dabble in that much web-related things, but the reason I wanted to check this out is I had this on my radar for a couple years because I was doing a lot of functional reactive programming at one point, and this was a language that kind of brought that to the forefront and was doing that kind of thing again for front-end web. So I thought it'd be pretty cool. Recently, they published an article called Farewell to FRP, which is the functional reactive stuff that I was interested in playing with the language. And I was just kind of reading through that, and I didn't really understand what they were getting rid of and what they were kind of replacing that stuff with, because I hadn't actually sat down and tried the language. So that's just kind of what I did. Yeah, that's kind of what this project was about. That's kind of what brought this on. Yeah, so there's basically the background. In terms of the project itself, I'll paste the repo here. It's just my GitHub/Elmsteroids. Right now, there's no README or anything, just because it's yeah, pretty early, pretty basic. I'll do that when it's more complete. And then I kind of want to show you guys where I'm at so far. By the way, if you want to check out Elm, that's elm-lang.org. I'm still kind of forming my opinions about it, so I'm not sure if it's there's some things I like about it and some things I don't like about it. Most of the things I don't like about it actually come from the fact that I'm comparing it to Haskell, and a lot of things that work in Haskell don't work in Elm. But a lot of things I do like about it, like one thing I really like about it is it's so easy to just get started with it. In terms of like a teaching tool to teach people functional programming, I think Elm's going to be really good. Right now, it's kind of in a transition period between their 0.16 and their 0.17. And I think that they're still catching up with updating all the examples and the documentation. But in general, it's I've had a pretty good time with this. Yeah, so let me go ahead and actually run my project. Oh, whoops, let me pump up my font size. It's something stream readable. So Elm has this thing called the reactor. I'm in my project directory here. Just run Elm reactor. And what this is going to do is it's going to set up a little web server that's basically just going to watch my Elm files. And whenever I make a change, it's going to recompile them to the equivalent JavaScript. And so if I go to localhost at port 8000, you can see here that I've got like this file navigator thing. So here's my project, the different dependencies that it relies on, and then some package information. So I'll go ahead and go into source, and if I go into main.elm, actually I've never tried going into just one of the other ones. Yeah, I can't. It tries to initialize it, doesn't have any main, so that doesn't work. But I'll go to main.elm, and now you can see that this is the Asteroids clone so far. So it's fairly basic. You can't see the ship because it's under this large asteroid here. So I can move around with my arrows, and I can shoot some bullets, and that works pretty well. As you can see, there's collisions with the bullets and the asteroids, so I just knocked out that asteroid. There's no collisions between the player and the asteroids yet, and the asteroids don't break up into other asteroids. There's also no fancy things like particle effects yet, and this will let me shoot quite a lot of bullets as well. Haven't really limited that. A couple other things you'll notice that are kind of cool. The asteroids do wrap like on either side of the screen. So like this thing here and this thing here are actually the same asteroid. So that's handled correctly, even for literally corner cases where you see this one asteroid is drawn on all the corners. You know, ship physics feel pretty good. The ship can also wrap. There it is, coming on the other side of the screen. There's a couple corner cases, like the wrapped versions of the asteroids don't work with collisions yet, that kind of thing. And in general, I wanted to not only make an asteroids clone, but one that actually felt pretty good. And that's why I'm considering things like, you know, particle effects and those kind of things. Sorokia, does it use canvas? I believe in this case it does. It all depends. So let me kind of show you some Elmy things. I'll show you my top level module here. One sec. Yeah, so here's my top level module, and you can see that my main here, which is something akin to an entry point. This is a purely functional language, so it doesn't actually have that, but basically what it has is that I'm setting up a program, right? And so we have an initial value for the state of my program. We have an update function that will, based on messages, also update the state of my program. We have subscriptions, which is things that can actually create messages for me to update the stuff, such as like an animation frame or the arrows. Then we have view, which is just a function from my data model to some HTML-like stuff. So if we go down to view, you can see that from my model, I make a collage, which is a Elm-specific drawing thing. And that's going to be, you know, the size of width and height, which I have specified in another module. And then I have this black rectangle for the background, and then I have, you know, my player and my asteroids and my bullets all drawn as sort of graphic elements. Then what I do is I take that element.toHTML, and I believe behind the scenes that these collages like this with these graphics elements do become canvas back drawing things. Frankly, I haven't looked that much into it, but I'm pretty sure that's what's going on here. But I never interact with the canvas directly. I just, in a functional way, I just describe the things that I want drawn, and I expect that the underlying library will actually handle the actual drawing. So that's pretty cool. And again, what makes this interesting is that this is, you know, purely functional. So I have everything in this language is immutable. I don't know if you guys are familiar with like Haskell, or in some cases languages like F#, OCaml, ML, or I guess some cases OCaml, and then ML I believe is also purely functional. But everything's immutable. So I have my model here, which consists of a player, so some state for a player, a list of asteroids, a list of bullets, some key states, which is like which arrows are pressed and when. And then I have a random seed, which I use to pass around random numbers. Yeah, that's another issue with this right now. Every time I refresh, it actually uses the same initial random seed. I need to see that with time or something. Yeah, haven't done that yet. Sakesy, that looks really cool, thanks. Sorokia, the syntax looks crazy. The syntax is mostly taken from Haskell. And it's actually quite a nice syntax for the stuff you're doing. By the way, guys, I gotta be right back. My food just got here. So I'll be back in like 2 minutes. Hey guys, I'm back. Haven't eaten that fast. I'm just gonna eat my food on the stream because there's some interesting discussion happening in the chat that I kind of want to be a part of. So some of the comments. I said that. Decites was saying that the syntax seems pretty easy, declarative like Haskell. I think it depends on your background, because if you're used to more of the C family of languages, the syntax is going to look very weird. If you're used to like the Haskell or OCaml, ML, that kind of family of syntax, then it's basically going to be very familiar. I think it's closest to Haskell, but it has some elements from F# that are definitely, yeah, influential. Lohenzo, I heard that React.js was inspired by Elm. That may be, because I know that they both sort of have that functional way of working where you just produce sort of a virtual HTML DOM, and then something underneath will handle actually putting that to the screen. So I know that at least the mechanisms are similar. I don't know if one was inspired by the other, but they did start generating a lot of buzz around the same time. That's why I started looking at this stuff. Dero2, I started learning F# because your NVC talk about your cool SNES demo authoring tool you wrote in it. Yeah, thanks, man. I'll link the talk. Yeah, sorry, links are disabled. It's because normally I'm coding some emulator stuff and I don't want people to, yeah, post certain links. This is the talk that Dero2 is referring to, where I used F# to, yeah, do some Super Nintendo stuff, is the short of it. But I basically got it down to a data processing problem, and then F# is a very comfortable language to do that stuff in, as well as being on top of .NET. So whenever you need a GUI and stuff, you can actually you have actual libraries too that are easy to use that you can go and use. I'm gonna start slurping some soup. But yeah, when I say that one of the things that, or I guess a few of the things that annoy me about Elm, annoy me because I compare it to Haskell. There are a lot of, especially syntactic things that are, first of all, different, and that doesn't really bug me that much because it doesn't make that much difference to me. But the bigger thing is when there are things that are like, I guess, kind of counterintuitive to me regarding the syntax. And I don't know if, I think I've refactored most of my code so that most of those cases are kind of avoided. But I do know that there were some. For instance, in key states, and I actually haven't tested Haskell here. It might act the same way. I have this case here where I'm converting a key code to some changes on my key states model. And I have this big old if statement where I should be able to do case key of, and then you would say, left, and then that stuff, right, that stuff. And yeah, the compiler didn't like that because it thought that left and right were the same pattern. And that can make sense if it's assuming that I'm just going to bind this value to this name. So that would make sense in the sense that this would be like a catch-all pattern that would catch everything and then bind it to the name left in this context. And that's why it thought that these patterns were the same. But what I wanted to happen was that, left and right are constants up here. So I wanted it to match the specific values of those and then return a different value here. And I didn't know how to do that, at least with Elm. But I'm pretty sure Haskell will try to resolve those names first and then understand if you're trying to work with constants. If I inline them, like if I did case key of, and then I inline the codes like 38, whatever, 32, whatever, and then it worked. But then I had to repeat all those key codes twice, here and here. So I thought that the if approach was just a little bit better in that case. So there's a lot of those kind of things. Decites, am I saying that right? Decites? I have a C language background myself, messed around with Haskell for about 3 weeks, and then I actually did some real work with Elixir. Same concepts. Dave Thomas is good book on the language. Yeah, I want to check out Elixir. Row 2, you have to make sure that constants have the literal attribute set. Otherwise, it takes to be a local variable name. Is that an F sharp or an Elm? Because I think in F sharp that does also happen. Well, hands in that case looks pretty much like Erlang. Yeah, it probably does. I think Erlang syntactically is kind of in the same family of languages, but I don't really know. Never used Erlang myself. Oh yeah, F sharp. Yeah, and there may be something there in Elm as well. Just those three things mentioning patterns. If in case. But in any case, this wasn't that bad. But it's just like at least one case that was subpar. Yeah, there may be a similar solution in Elm. I'm not sure what it is, but that's not that big of a deal anyway. So in general, the kind of how my code is structured is kind of as you'd expect. I mean, I have some utility modules, like I have a vector module, which just gives me a tuple of float and a float, and then various helpers, length, add, sub, mul. I might rename this magnitude because I keep that keeps conflicting with like list.length and stuff. Wrap is one that I have here, so you can wrap a vector within the bounds of another vector, and that's very useful for doing like the wrapping in this particular game. I have like a triangle module here that just defines a triangle of 3 vectors, and then you can check if a point lies inside that or not. And so I'm using that for collisions. Another one I have is state. So Elm doesn't have higher kinded types, which means it doesn't give you definitions for things like functor or monad or applicative or any of those. But what you can do is you can still describe most of those things as long as they just have simple type arguments like this. So like this is just a classic state monad if you're familiar with that. And I use this for like random number generation stuff. I use this for, also in the asteroid bullet detection stuff, or collision detection. See, it's pretty close, but it's dynamically typed and uses macros. Pure functional, but not quite like ML. Was that Elixir? Sorry, I lost the context. Row 2, yeah, it looks like you can't match on literals in Elm. Check a look at that discussion link, actually. Yeah, I think you guys can send me links, which is, I believe, what the Row 2 just did. And then I can post them. Oh yeah. Sorry, Erlang Elixir. Okay, gotcha. This is a link where I guess they were talking about the fact that you couldn't can't match on literals. That's all right. That's not too bad. Yeah. By the way, Zachy McHarvest is one of my mods, so if you send him links as well, he can screen them. And he'll probably get to it faster than I will. So what was I going to work on next in this game? I could work on changing the random seed, because that's getting kind of annoying, testing with the same asteroids over and over again. So again, if we go back to the main module, it has this program with an initial value of my state. So when you're in a purely functional language and you want to have state changes over time, it's not like you just have an object and then you say, oh yeah, now the player's position is this. You actually have to create a new player object and create a new encompassing model object around that. So again, that's what this model is here, which is just all my state. ZNC, this is so fascinating. Cool, glad you think so. Row 2, isn't that useful for debugging though? Oh, you're saying that it's the same asteroids every time? Yeah, kinda. I mean, I'm not really like debugging very specific things. It's more like, oh, I just want to fly around and shoot some stuff and make sure that works and like grazing collisions and things work. And it's just, I guess with this particular asteroid configuration, it's annoying. Plus, I need to do that feature anyway. Yeah, so you have this model here, and everything here is immutable. So then I have an init, and this is just it's actually a pair of a model and then a command that I can send, and I never end up using those. But the point is that I'm returning my initial model. That's really what I use for this. So I have initial random seed. From that, I initialize the asteroids, which will give me the asteroids list and a new random seed. There's kind of a reason why I do it this way. But then I just create, a basic player, put my asteroids in there, make an empty list of bullets, default key states, and I store my random seed so I can use that later. And then all that goes into this model object. Of course, then that's packed up with a command. And this is useful if you want to just like set off a command like a web request or something right as your program starts. And the Elm runtime will handle sort of all those side effects. Jacob Mishka, good to see you. And then, so that's my model and the initial value. And then I have this message type. And messages are used to actually change your model. And so this describes every kind of way you can actually change the model in this case, or any valid way that I've said that the model can change. So you can have a tick, which is going to be like a frame basically, and then it has a float, which is going to be the time. I am aware that Elm has its own time construct, but I found it more convenient to just use floats everywhere and assume that everything's in seconds instead of using Elm's time type and then doing like 2 seconds everywhere, because that's the only thing I was using. So I just went with that, added this comment, and that was my duct tape. And then you can have, if a key was pressed or a key was released, you can get which key that was. And so the thing is, then you have an update function. An update function will take one of those messages and a current model, and it will produce a new model and optionally a command if you want to issue other commands as well. Again, I never use the command system, so you can kind of ignore that. But like in this case, so I take an update with, or a function update with a message and a model, and I switch on the type of that message. So if it's a tick, then I actually go and tick the game, produce a new model. And otherwise, if the key is pressed or released, then I make a new model where the keys, a new keys object is produced by some functions in the key state module, key states. Then we have subscriptions, and this is actually where, so both in the subscriptions and the view, but only the subscriptions in my case, you kind of hook up and tell the rest of the system what kind of messages it can produce to give you to go and change your model. So given a certain model, I can make like a subscription or a list of subscriptions that says these are the things I care about. When they happen, send me some messages. So for example, there's a diffs function here. Yeah, so it's sub.batch is just like you give it a list of different subscriptions, and it will just treat that as one subscription. So that's just kind of how you wrap it up in a list. And so here diffs is a function. I can't remember what an animation frame in that module. What that's doing is it's every time there's an animation tick, it'll send me a message, and then that message will, be in Elm's time type. But then so you give this a function, right, that will take in. If you're not familiar with functional programming, this will look kind of weird, but this is kind of the easier way to say it. If you're not familiar with that, then we'll do. Let's write it this way, or actually we'll write it like this. So what this does is you give it a function that will take a time value and produce a message, right? So in this case, whenever it gives me time, I create a tick message where I've converted the time into seconds, right? And then this is just another shorthand for writing that, because in seconds is a function that will take a time value and produce a float that represents the seconds, and then tick is a function that will take in a float and produce the tick message with that float data attached to it. So I can bind these functions together. If you're familiar with functional composition in math, where if you have function f, and then you have function g, you can do f dot g, pretend that that's a dot in the middle. What this will do is it will create a new function that will like take a value, pump it through g, and then take the result of that and pump it through f. And so if I had written that like the composition operator in Elm looks like sort of the shift left if you're familiar with C-like languages. So yeah, so you can think of this as going the other way. But I prefer to write it this way because it sort of shows the data flow. I'm making a function that will transform a value to seconds and then put that value in a tick thing here. And then I pass that function to the diffs. So yeah, so all that's really doing is just every frame it's going to make sure that I get a message that's going to be my tick message, and it's going to have seconds as the argument there. And then downs and ups are key messages, and so I just go ahead and wrap those in key pressed or key released message types, and then those go through my update. So whenever a new message comes in, you get an update. Whenever a new update comes out, you get new subscriptions. And so if you want to unsubscribe from something, like if you want to subscribe for something, you just describe that you're subscribing to it. If you want to unsubscribe, you just don't return a subscription, and it will maintain, you know, this. If you have the same subscription over different frames, it will maintain that. CN69, you're so bright. Man, I just read a lot of code. But thank you. And then yeah, also when a new model is produced, it will be pumped through this view function, and then the result of that gets checked against what the DOM already looks like in the web in this case, and then we'll do updates. Dero, is that like piping in F#? Actually, that's a good question. So you mentioned the forward pipe operator. This is actually, this operator exists in F#, and it's actually the same thing. What you're describing is forward pipe, and so let me kind of show you the difference. I'll kind of write something to show the difference there. So let's say we had a list, right? So like, how do I want to write this? Derp is my function, right? We're gonna derp a list. So we can take the list and forward pipe it through something like list.map, right? And then we'll give it a function. So for every x, we'll do, I don't know, y, constant function. And then we can do, I guess, list.filter. For every x, we'll return true. But see, so what this is showing is we're going to take the list, and we're going to pump it through this function, and then pump it through this function. But we could also rewrite this, because like you'll notice that list is only used here, and then only here. If we wanted to get rid of that, we can just say, well, instead of like taking this object and piping it through there, and then piping the result through there, why don't we just make a function that's these two things put together, right? And so we can rewrite this as, we'll rewrite it like this, list.map list, right? So we get kind of our same thing. But instead of the forward pipe, I'm going to use this other operator here. And so now I've created a function that's these two things put together, and then I can like pipe list through that, right? See how that kind of works? I think it's easier if I do that. So I've created a compound function here, and then I'm just piping list through that. But then it's like, why would you then write this? Because remember that this expression will return a function that just takes this argument. So we don't need to do the piping explicitly. We can just say that the derp function is that, and then that list is sort of implied by the fact that these are chained together, if that makes sense. So this operator does exist in F#, and I believe it comes from F# as well, because I don't think I've seen it in Haskell. I'm sure they have an operator that's exactly the same thing, but I don't know what it is. So yeah, so that's what this function composition thing is. Soup break. And an alarm. All right. Cool. But that's the basics of it. Is that we have this we have these messages that the runtime will give us based on different states. We have an initial model value. We have a function to update the model based on these messages, and we have a function to display the model here. And of course, I basically just split all the updates and displaying it to different functions that will handle the different parts of the update or the different parts of that kind of stuff. So for example, if we look at tick, we have, we take in the original model here, and when we have a tick message, we're going to take the model's asteroids, and we're going to call asteroids.tick on that with some other information like the time delta, which is, how much time has passed since the last frame. And that will produce a new asteroids value, right? So I'm using this let expression to just hold those temporary values. I do the same thing with bullets. So I take the bullets. And then what I do, the reason I do these separately here is so that then I call collide on them. And collide will take a list of asteroids and a list of bullets, and it will return a new list of asteroids and a new list of bullets. And the reason why it needs to do that is because, for example, if an asteroid and a bullet collided, you need to remove both that bullet and the asteroid. So you need to produce a new list of both things. So then I have asteroids prime and bullets prime, which is what this quote here denotes. The thing is that, again, if you're not familiar with this kind of language, this quote here is actually just a valid part of this identifier. So it doesn't actually mean anything special. It's just a kind of a mathy notation that you can use. So if I'm just creating a new asteroids prime makes sense. Duro 2, so every frame, are you creating a brand new model instance rather than mutating your existing one? Yes. Yeah, that's what I'm describing here, is that, every frame a tick message will be produced, and then that will get pumped through my update function, which will take the previous model and the message and then produce a new model. So in fact, this expression here is what's actually creating the new model. And so if you look at this again, we get the new asteroids, we get the new bullets, we get the second new asteroids and the second new bullets from handling the collisions, and then we create the new model here where we say this object is going to be the model with, is what this pipe thing means. The player of the new model is going to be, the new player after we tick the player as well. And then the asteroids and the bullets, and then we're also going to do a keystates.tick. And keystates needs a tick for how I handle whether or not the space key was tapped. Duro 2 says, is this technically slow? It's going to be slower than the immutable equivalent, but it's not going to be slow enough to make much of a difference. The other thing is that in general, it's just a different kind of programming model. The only reason it's slow is because it's different from how the machines work. But you could have, in theory, a sufficiently sophisticated compiler that would be able to, probably turn this into a mutable equivalent. And on the other hand, you also get a lot of really nice benefits with having everything immutable. Like this will, automatically work if I start introducing, fork join threading points. So if I wanted to, tick the asteroids here and tick the bullets, I could do those on separate threads and then just join here when I collide. This language, I don't think actually has any facilities to do that, especially because its runtime is, JavaScript, which is going to be single-threaded. But theoretically, you could do that. In general, it's just a different way to think about programming and write a program. So I think speed is just not your first concern if you're doing things this way. I think what you'll see later is that the code might look a little weird, but it's shorter. It's a lot shorter than the mutable equivalent. Number 2, I'm super fascinated seeing games coded in a functional way. Yeah, this is the first time I've done it completely functional, and it's cool to see it work. I think a lot of Elm projects are games though like this. People, wrapping their head around the language with these kind of projects. So then if we look at some of the tick methods or tick functions just to kind of show you what that might look like, we'll take a look at the player. So the player is just an object that has a position, a velocity, and a rotation. And so its position is where it is on the screen. Another interesting thing about Elm is that normally when you're doing graphics, you have a coordinate system where you have the top left corner is your origin, so that's 0, 0. And then you have the x-axis increasing in the horizontal direction this way, and then the y-axis increasing downwards, down your screen this way. But Elm actually has 0, 0 as the middle of whatever your thing is. In this case, I guess it's my canvas. And that can be a little different, but it's really doesn't make much of a difference. So we have the player. And yeah, so it needs its position, which is where it is on the screen. It needs its velocity, so it'll just keep going, and it needs a rotation. So our keys are just going to really be rotating the player left and right, and then when we hold forward and backward, we're going to accelerate or going to have some angular acceleration based on the rotation. So the interesting part here is the tick function. So it takes a float, which is going to be our time delta. It takes the key states, which is the current state of the key for that, all the keys for that frame. It's going to take a player, and then it's going to produce a new player. Yeah, so tick, time delta keys player. So what I do is I calculate a new position by adding the incoming player's position to the velocity multiplied by the time delta. And then I also take that position and I wrap it with the bounds. So that we get a new position. As you can see, it goes down off the bottom of the screen, comes back on top. So that's what's happening there. That's the updated position. Then I have an acceleration constant, which is just some random number that looks good with my time deltas. I calculate different kind of values, like if the keys is up, then I have this up acceleration be this acceleration value, otherwise it's going to be 0. I do the same thing with down, but in the other direction, and that's so that I can hold both and it cancels out, because I think that feels better than just doing one or the other. And then I calculate my whole velocity delta, which is kind of a bad name, but in that case it's going to be the up acceleration versus the down acceleration. And then my new velocity is going to be this vector, which has 0 on the x, and then the velocity times the time delta, rotated by the player's rotation, and then added to the player's existing velocity, and that's how I calculate the new velocity. I basically do the same thing with actually rotating the ship. So I have a rotation speed, and then I do left delta and right delta, which is like the same pattern. Then I add those together, and then I just add the old player's rotation with the new rotation delta times time delta. The reason I don't have to do like add and rotate here is because these are functions that are operating on vectors, whereas the rotation is just a float. So yeah, so I get all those new values. I get the new position, I get the new rotation, I get the new velocity, which is basically everything. And then I construct a new player. In this case, I use this update syntax where I have the player where its new position is this, its new velocity is this, new rotation is this. I could have just as well simply wrote it like this, where I don't actually update it, because I am actually writing, all the fields, so I don't need to take the ones that I don't mention here from the other player and copy them here, because there aren't any. But maybe if I add something to the player, that might be the case, so I just kind of leave it like this. But that's the whole thing. So yeah, when we take the player, that's about it. Take the key states and produce a new one. The player is very simple, and there's also no collisions with it, and that helps with keeping it simple. Yeah, and then of course there's a draw function, which goes from a player to, in this case, a form, which is, I guess, I'm not really sure what the exact description of a form is in the graphics library. I kind of just found the type that the compiler wanted it to be. But I guess it's like something that's higher level than a shape, has more information. Like this is a shape that's moved to a specific position as well. Nelman says, can you explain the time delta super quick? Yeah, the time delta is the time in seconds between when the last frame happened and the current time when the current frame is happening. And that's used to, like, if I have different frame rates, like if this is running faster or slower in a different browser, all the physics should act still relatively the same. Like if I'm holding up and if my ship starts in the middle of the screen and I hold up, then after like 5 seconds it should be at the top, and that should be kind of regardless of frame rate. It's not gonna be perfect, but it's better than not doing anything for that. Duro 2 is Mullen, the times operator the same. So yes, the times operator is just operating on simple values like floats and ints. And then the mul function is a function that I made for vectors, but it does just multiply 2 vectors. And I believe I can actually overload this operator too, instead of actually typing out mul. I just haven't done that. I probably could do that. It'd probably make my code cleaner. Yeah, so then the draw function is just going to take the player, pass its position and rotation into ship.draw, which I have another module that defines the player's ship. And I put that in a separate module for a couple reasons. The first one is that, it is kind of its own thing. Like the ship is kind of decoupled from the player. Like the fact that the player draws a ship is really the only coupling they have. But the other thing is, like when I fire a bullet, you'll notice it comes out of the nose of the ship and not the center of the ship. And so I use the separate ship module to be able to calculate the ship's metrics without having to rely on the player module, because that just didn't feel quite right. yeah, so all this is doing is drawing the player, and then I pass that form through a draw wrapped function. And what that actually does is it takes the form that I specify from drawing the ship, which is going to give me this little triangle, and it's also actually going to give me the lines and everything. But then it's going to repeat it 9 additional times, right? Or sorry, repeat it 9 times. So it's going to have the one in the middle, and then it also draws it. Let me refresh this again. So it'll draw one here in the middle, and then we'll also draw one up here. So like at its position plus the height, and also minus the height, and same with the other directions, and then also in the corners. And that's actually just how I handle having it wrap on the different edges of the screen. And what I want to do with that actually is also have it like not generate ones that it definitely doesn't need. So for instance, it always draws 9. So even if I'm over on this edge of the screen, it's always also drawing extra ships way out here on the left when it definitely doesn't need to do that. So there's cases like that where I can optimize it, but it doesn't really matter. Ep.001 says, I thought you could move backwards in Asteroids. You probably can't, but I wanted to be able to. It's very easy to turn that off. There you go. Now you can't move down, but I want to. Yeah, so that's the whole player. I can show you the ship module as well, but it's not very exciting. It has this front, left, and right functions, which actually give you the points. So if you give it a position where the ship is and then a rotation, it will give you the resulting front, left, or right point. I think only the front, only the front is actually exposed from this module. Like it uses left and right internally, but you can't actually see those functions from outside of this code. But you do need the front one, like to be able to fire bullets. And then it has a draw function, and the draw function is just going to take the position and direction. It's going to do some, actually call the front, left, and right positions on there, and then, do a polygon between those, an outlined polygon, in fact. So all this stuff gets very clean in terms of like, there's like no code here. Bullets get a little bit more interesting. Slurp some soup, and I'll talk about that. So the bullets have a position and a velocity, as you might expect. They also have a time until death value, and that's a float in seconds. So when I fire this, after about 5 seconds, you see it just fades out, and then it's gone. And Ep.001 says forward piping is awesome for code clarity. I totally agree. Forward piping, and also this, I think it's called I know it's not function composition operator because that's the other side, but it's reverse function composition. I'm not actually sure what that's called, but I love that thing. Lohenzo says, how do you serve those files? This is all running in the Elm reactor, which is a thing that just watches my local files on the local file system. And whenever it changes, it will generate new JavaScript and stuff. And that runs a little local web server. So when I navigate to localhost on port 8000/source/main.elm, then I get that. But so the bullets have position, velocity, and then that time until death. And that's when a bullet's created. That time until death is going to be 5 because it's 5 seconds, and then that's slowly decreased every tick for that bullet until it hits 0. And then I also happen to use that value when it's drawing, which is why it fades out. So if you look at tick. Tick is a function that takes float, which is going to be our time delta, the key states, because we actually fire bullets in here, and then the player, so that we know where to fire those bullets from, and then the previous list of bullets from the last frame, and then the new list of bullets for this frame. So all I do is I just pump these arguments through the fire bullet function, and here I'm using this composition again, and then a filter map where I both move and potentially kill the bullets. So to kind of describe how that's working, fire bullet, as you can see here, is a function that takes the key states in the player and the previous list of bullets and then produces a new list of bullets. So what's happening there is when I only apply 2 arguments, what that returns is a function. So I kind of have to describe partial application here, which is fine. So I have a function here that takes 1, 2, 3, 4 arguments, and then will produce a result. But if I call that, so if I call tick with some float and some key states, some crap. By the way, space is function application in this language. And then, my player, I'll do this, keys, player, bullets, then what this will return is a new list of bullets. I'll call that bullets prime. But what would happen if I do tick 0.0 keys player? What would that return? And the answer is this actually returns a new function that will take in bullets and produce, bullets prime. So it will actually return a function. This is really useful, and this is called partial application because it transforms my function from this type into a function of this type, where it's just the list to the list, and that's really, really useful. So that's what I do here, is I take fire bullet and I only apply the keys in the player, and that will give me a function that expects the bullets. And then I have this filter map function, which will also expect a list of bullets. So I can just put these two functions together like this. That's pretty nice. Drew2 says currying. Yes, I didn't want to bring up that term because I didn't feel like explaining it, but why not? So currying is like the process of taking a function that takes multiple arguments and splitting it into a bunch of nested functions that return other functions. The point of it is that you end up with all your functions only actually take one argument, but then the advantage is that partial application that I just showed. So if I have a function, which, let's just dump this here, so some room. If I have a function that takes some value of a and produces b, this is a very simple function. I can call f of x, for example, and it will give me, we'll say that evaluates to. It will give me, some value, some a, or actually it will give me a b in that case. But then if we take an f, a, b, c, you can expect that I can do, actually we'll call that g. You can expect that then I can call this with a and b, and that will evaluate to a c. But then again, we have those that partial application. So if I just have g, it will just give me a function, right, from a to b to c. That's fine, right? But then as soon as I give it the a, then that gets kind of baked into the function, and we get a function that will take a b and produce a c. Instead, when we give it a b, it will produce the c, and that's where you get that. So currying is the thing that takes a function with multiple arguments and then allows you to return these functions that take other arguments when you only apply certain things. So currying's that process, and then that gives you partial application. Partial application is the act of only supplying some of the arguments and then getting the function back. But again, that just allows me to take fire bullet and just apply enough arguments so that I get a function that takes a list and will produce a new list. Do the same thing with this filter map stuff. So that's a function that takes a list and produces a list, and then I combine those two. So I'm going to do is I'm going to fire bullet. So based on the current keys and the player position, it may produce a new bullet or not. So it's going to produce this list of bullets with either a bullet tagged on the end of it, or it's just going to be the same list. And then I'm going to take all of those, and what filter map does is it takes that list and maps over it. So for example, if move bullet with a time delta will take, move bullet takes a float, a bullet, and produces a new bullet. So if I only apply a time delta to this move bullet function, then this is a function that takes a bullet, produces a bullet. And the same thing with kill bullet, takes a bullet, produces a bullet. So these two together is just a function that takes a bullet and produces a bullet. So filter map will map over the list that it takes in, apply this function to each element, and then that will return a maybe bullet down here. And if that was, had a value, then that gets included in the new map that it's creating. If it didn't have a value, it doesn't. Duro2, is saying that also this arrow thing is a consequence of the currying. it's a syntax that kind of makes that explicit. Just saying that this value from here to here to here to here to here, instead of doing something like in C, right, where you would say like C++. Tick, where it, had the right there, where you kind of have a differentiation between the argument list and then the thing. So, syntax kind of makes that obvious. Anyway, firebullet just takes some extra data, but the point is it takes list of bullet, returns a new list of bullets, and that's just saying if the keys .space tapped was true, then we're going to create a new bullet here, where the position is going to be the front of the ship based on the player. The velocity is going to be the player's velocity, and then we're going to add some value that's rotated by the player's rotation, and then the new time until death, and we just take that and we slap it on the front of that list of bullets, and that gives us our new list. If the space wasn't tapped, we just return the old bullets. So that's all that's doing. Move bullet, now we're on the per bullet level. It just takes a time delta and a bullet and then the new bullet. So all this is doing is producing a new bullet where the position is the old position plus the velocity times the time delta, and of course wrapped with the bounds there. So that's very simple. Kill bullet is slightly different because kill bullet, it's maybe not the best name. It takes the time delta and a bullet and produces maybe a bullet. And what that means is that, like, so for every bullet, we're going to take the time delta. We're going to see if this bullet needs to die, basically, based on its time until death. If it doesn't need to die, then we're just going to return the bullet. Otherwise, we're going to return nothing. So if we look at this, we see it takes the time delta and a bullet. We take the new time until death, which is going to be the other bullet's time until death minus the time delta, which makes sense. And if that new time until death is greater than 0, good, we still need the bullet. So we'll return just, which is saying that we are going to have a value here, and then the object, which is the bullet with the new time until death. Otherwise, we produce nothing. And then that filter map will then, filter all of those and take the ones that produce just with a bullet. Otherwise, it's going to discard them. So you could also, when you're talking about performance, you could argue that this is not the best way to do it, because I'm splitting up all the different logical things that can happen to a bullet into different like functions and mappings. You could argue that would be slower. You're probably right, but in general, it's going to be fast enough. And this is a really nice way to just do all these things separately as separate steps, which is generally a good way to do things. Draw is very, very simple. It's going to take a list of bullet and produce a form. And all it's going to do is map our list of bullets with this draw bullet function, which for every bullet will produce a form. So then we have a list of forms and just pipe that into this group function. So it's just going to produce a group where, group of these forms produced by the bullets. So then we have a draw bullet function, which is, a singular bullet into a form. And that's very simple. We just take a 2x2 rectangle, make it filled with white, move it to the bullets position, and then give it some alpha based on the time until death. That is the whole bullets module. And that's pretty good. There probably isn't that much more interesting stuff to... Here's my wrapping drawing. It's just going to take a form you give it and then put it in a group with itself and a bunch of other forms based on the different wrapping stuff. And then the only other stuff that's really in here is the asteroids and the collisions. And of course, I can show you the key states, but it's not very exciting. We just have the press and release functions here, which given a key code, if it's a key we care about, it's gonna set that current key state to true. So we have like left, right, up, down, which is whether or not those keys are hit. And then I have space tapped, and that's gonna act a little bit differently. So as you can see, when I get oppressed, I always, depending on these keys, I just set, a new keys object where right is true, or up is true, or down is true, depending on the key, or space tapped is true. Released, I just set all those to false except for space tapped, which we'll get to here in tick. Tick is just the keys where space tapped is false. And so what I'm actually doing here is, for space tapped, when the key is pressed, you're going to want to set that to true, and then let it go through a frame where it's going to actually use those states where space tap is just true. But then as soon as that frame's over, I want it to be false again. So that's just saying like, instead of having space tapped like stay true while you're holding the key, I want it to just fire once. So that's all I'm doing there. Otherwise, it's pretty straightforward. Also, one of the things you'll notice here is that in the syntax, for example, with this press function, I say pressed has this type where it takes key code and key states, produces new key states, and then I have the function definition. You actually don't need to do this. You'll notice that I'm basically not writing types almost anywhere except in my type declarations, and of course above all the functions, but that's just a convention. The compiler will actually figure this out. It has really good type inference. But it's customary to do this because it's kind of good documentation. Like if I just opened this and I had written it, this kind of thing would be nice to know before I had to read through the code and understand what the types are gonna be. But yeah, so this is a strongly typed language. It's not like JavaScript where everything's just an object and then, you know, it's strongly typed and there's a lot of type checking, and that's one of the things that makes this language cool. So for example, if I, you know, change this true to 6, or 3 is the key I ended up hitting, then we get a compiler. So now it's going to say type annotation for press does not match this definition. So this is the definition we gave it, which is what this is. It says the type annotation is saying this, right, where it's going to produce keys where left is, you know, Boolean. But it's inferring the type definition actually has this type, where left is actually going to be a number. And that's consistent with what I wrote here, but not with what I wrote here. So that's exactly what it's telling me. So we catch all those compile time, which is really good. Not at runtime as it's running. So it makes our programs probably less buggy. Generally, the idea is if it compiles, it'll work. You can see that flash of the logo, it's rebuilding because I changed the files and refreshed. Yes, so then there's the asteroids, and this is where stuff gets kind of crazy if you're new to the functional stuff. And I don't know how deeply I want to go into explaining some of this stuff, in particular this section here, where it's actually generating the random asteroids, because I don't really want to describe monads. But the thing is that I have to do a bunch of calculations, like in this case, producing a random number. Or producing a bunch of random numbers. So I want to produce an asteroid, and the asteroid has a random position, it has a random size, it has a random direction, it has a random velocity, it has all these random things. But I can't just call a random function and have it return me, you know, like a different value every time, because that doesn't work in a purely functional world. You can't, that doesn't make any sense. A function in a purely functional language will always return the same value no matter what parameter, or like if you give it, if you have a function that takes a number and produces a number, and you pass in 6, it will always give you the same value back. If you pass it 3, it might give you a different value because you have a different argument, but for the same set of arguments, you always get the same value back. That's called referential transparency. It allows you to do things like inlining, a lot of other cool stuff. It also makes testing a hell of a lot easier. But then it becomes problematic when we want to call like a random function to have it produce as a random value and have it produce a different random value every time, because it literally can't do that. And so what we have to do is, instead, when we produce a random number, we give it some state. So we say, hey, here's like the bounds of the random number that I want, and here's the random seed that I currently have. And instead of just returning the number back, it will return the number and the new seed. And so that's what you see here. That in asteroid takes a seed and it will return a tuple, so 2 values, where one of them is an asteroid, the other one is the new seed. Now the problem here is that that's all fine and good, and we have some syntax to make that a little bit better. The problem is that this is kind of like, you know, let me just kind of write some of this out to show you guys, because it's actually very interesting. So let's write a very simplified version of this. We could just like pretend. So I'll do the same types here. Oops. Seed is this. So what we want to do is, let's say we want a random position. So we say, okay, so we're going to say let x is, let's say we have generate float. Number 2 says, this is super interesting. Thanks for taking the time to explain it. Yeah, no problem. This is actually something that I struggle with a lot, and I kind of want to use you guys as a test subject to see if I'm explaining this thing well, because it's something that I want to be able to teach. So let's say we have a gen float function that's going to take like a min and a max. So we'll just say left and right in this case of x, and assume that that's going to be our bounds. I think I actually do that here. That's what this means, but I'm just writing it a little nicer. 6 who's listening to you explaining stuff shows what a shitty programmer I am. Well, I think programming and explaining are different skills. So I think, I don't know. People are good at different things in programming even. So like, there's probably a lot of things in programming you can do that I don't know. Yeah, so we're gonna say like this. Let's just pretend that we're in a mutable world, and we just wanted to say this, right? Top, bottom, or actually bottom, top. In this coordinate system. And then we're going to say in this expression where x is x, or actually we do this, position is xy, right? Again, the problem here is that this won't actually work, gen float here, because we need to pass in the seed and then take out the new seed, right? So let's go ahead and do that. Or actually, let me write out the type for gen float to make that a little clearer. So gen float has the type, in this case, float to float to, well, we want it to have this type, where we'll take in, you know, min and max and then give us a float. But that's not actually how it works. It also is going to take a seed, and then it's going to return a float and seed combo, because it's going to take the seed that the state that you give it, and it's going to return the value and the new seed, right? Dura says, 6 you here watching this can't be that shitty. So true. You're curious, you want to learn. That is totally the most important thing. So yeah, so this gen float function actually has this type. So when we call this won't work. We need to actually say, in this first case, we're going to say x and seed prime with seed like this. And so what I'm doing here is I'm taking gen float, and I'm going to give it my left, right, and my seed. So that's all these. And it will give me, you know, a set of values that's going to be a float and the new seed. So I just bind those values here. It destructures everything for me. And then the problem is then, when I call gen float here, I can't use the same seed, because that's not what my seed is at this point of the program. My seed is seed prime. So I pass in seed prime here, and what do I return? Another seed, like this. And that sucks, because now I have, yeah, this seed and this seed. And then also remember that this is wrong too, because we're also going to return this new seed out here, so we have to do this, seed prime prime. And the thing is that this gets worse. So like, in this case, I have an object that just has a position, right? But what if I also wanted to add a rotation? And that was going to be a random rotation. Now I also have to do rotation. The next seed, prime prime prime, is gen float, I don't know, 0, 2 pi with that previous seed, and then I have to go down and change this again, right? And so you can see how, when I want to do a simple thing like piping a state through my computations, that this gets very ugly very fast. So we have a thing called monads. And if you go and Google monads, do yourself a favor, and if you're not used to speaking the language of math, try to ignore all of the references to like set theory and category theory, because at least in my experience, that was very confusing. It still is in a lot of ways, because I'm not a category theorist. I'm a programmer. So I have a different language in my head. I have a different way of thinking of things than a lot of those people would. So it's just a lot of kind of noise. But what, how do I describe this? A monad is a thing that allows you to construct and sequence, construct a set of sequenced operations that have some additional functionality. So for example, the operations we want to do is generate a float, generate a float, generate a float, and then, you know, create our object. That's a sequence that we want. but then because we have the state, we also need to pass the state around, right? So what we would like to do is be able to abstract that to say, look, I just want to describe the steps that I'm going to take, like just generate, return object, and then have something else handle the actual passing of all this state. And so we have actually a state monad that will allow us to do that. So instead of actually, doing these calculations here, what we're going to do is we're going to describe these steps of calculations. And then what that will give us is an object that we can then give a seed, and it will do all this work. But then all this passing between these will be done for us. Am I making sense, or am I losing people? Because this is something that's a little bit hard to describe in words. So I kind of want to talk about the solution to this now. And I'll give you a hint, it looks like this when you use it. Looks a little less ugly in Haskell, because Haskell has syntactic sugar for this case. But what we basically want to do, if we wanted to describe this step, Drus is kind of like metaprogramming. Yes, we will. This is metaprogramming. But the thing is that I think I'll just describe the exact case of what we're going to do. So the thing is that we have all these steps here, and each step is very interesting because each step actually has the same form as this function, right? When we want to generate x, this genfloat thing here, after we apply left and right to it, has this form, right? We've applied left, we've applied right, and then what's left, it'll take a seed and then it will give us a float and a seed. So this part has this form. This part has this form. This part has this form. This part almost does, except it won't actually do anything with the seed. It will just pass the seed through from what it was, at this point, and put it here. But so those are the only two cases. We have a case where we have this exact form as is, and then we have a case that's almost exactly the same. So we could think of these steps as like a container, right? So instead of actually doing the work here, instead of actually calling this function, we can produce a step that will look like this, that will be our step. So let me write that out. Let me say step. Space Cat says, speaking of math and programming, am I wrong in saying that you don't need to be good at math to be good at programming? I mean, I've never been good at most math. I'm okay at geometry, but I'm okay at programming. Yeah, I think that's true. I think programming is kind of its own math. Like you can take, I think programming and math are actually much more deeply related than people realize. But you don't need to be good at one to be good at the other. But I think you have to. The way in which you think about things at some abstract level is actually very similar to the two. Like, programmers have really heated arguments about like what kind of method is best or how to handle things. Mathematicians do the same thing. Programmers like to abstract things. Mathematicians do the same thing. Languages like Haskell and functional languages is where these things kind of start to meet again, but you really don't need one to understand the other. In fuzz, logic isn't math, it's related. But you need logic for both math and programming. And so it's kind of at that level of abstraction. So like I'm really bad at parsing math. Like I can't really read mathematic papers, but I can read a lot of papers about programming. Like completely different languages and completely different ways of thinking about things. I'm good at math that I can conceptualize and visualize. I'm pretty bad at when math gets sufficiently abstract. I'm pretty bad at it. Like set theory, category theory, no way. Not in my pay grade. But so what I'm going to do here is I'm going to describe this step here, right? So as I've been saying, step actually has this type. We're going to say step. Looks like this. I believe that's the syntax. Not that important, but so now I've described what a step is, right? And so we have all these functions here. So if I take this expression here, Or let's actually rewrite this. That returns a step in our computation, right? So given a float and a float, I can have a step. Okay, that's cool. Right? Because now I have now I can put this together as a step in my computation. I can put this together as a step in my computation. So if you think about it, if we have our bind operator first, I can take like gen float. Let me tab this out. Left right can be combined with gen float bottom top, right? Because now we can combine steps like this, which is fine because they're basically just functions. Now this doesn't actually work, but you can kind of imagine that this is what we're going to be doing, is we're going to start sequencing our steps. Just so happens that the operator we do that looks like this. Let me start kind of rewriting this, and I'm going to leave out some parts that I'll come back to later. Right? So this is kind of how more we want to write this. Does this make sense? How you can kind of see how these are the same? In fact, I'll do this. And then we'll put step up here so you can see stuff better. So what we're saying is if we have a function that will give us a step, let's make this operator that allows us to sequence steps, right? In fact, we'll do this actually. And so we have a step that'll generate a float, we have a step that'll generate another float, we have a step that'll generate a third float, and then a step that will return our object. Let me describe to you where the problem lies. By the time we want to construct our object, we wanted to, take the things that these steps would produce, right? Because this step will actually take a seed and return an asteroid and a seed. Now we're kind of trying to hide away the seed, so we're not going to worry about that. But we are going to worry about the thing that this gives us. So oops. This actually needs to be abstract like this. Sorry if that was confusing. But this is just saying a step can produce basically any value, but the seed part's always going to be the same in this case. So this step is going to produce a float. So A is going to be float in that case. This step is going to produce a float. A is going to be float. So on and so forth until this step where A is actually going to be an asteroid. But we can still chain all these together because they're all just going to be piping some seed through some computation. So where this goes wrong is that, once we've done this step of the computation, when we actually do it, we need to take that result. We need to take whatever this A was out of it. So the way we write that is actually like this. And I'll kind of get to Y in a second. Right? But this is basically what it's going to look like. And then we have one more thing, which is we're gonna write the word return here, and we'll get to that in a sec as well. But then, so now here we've described basically the same thing. In an asteroid is going to be a function that takes a seed and produces, some state, which is an asteroid, and then a new seed. But all we've done is we've just returned the steps to do this, which is pretty cool. So then you ask, well, how does this kind of work? Well, if we look at these steps again, you'll notice, remember, they were all in the form of this step. They took some objects and they returned a step, right? So we need a kind of function, or we're going to be operating with steps. In fact, steps of different values. I want to look at this chain operator here. We actually call this bind. Bind, I want to look at its type. So bind on the left takes a step of something. That makes sense. But what is this on the right here? What that actually is a function, right? That will take an A and produce a new step, right? So this is actually just a lambda expression. If you're used to lambdas from other languages, it's just a nameless function that takes an argument called x and returns a value. So you'll notice that all of these little steps here have these lambdas where they're going to, take some value here and produce a new value. And this new value is going to be a step, right? So we have an incoming step, we have a value that takes this unwrapped value from here and produces another step. And then that will produce a new step as well. James 5, what is this language? This is Elm. And so what's interesting here is that, you know, we have all these things like gen float where we give it some regular values and it will produce a step for us. But the step isn't that useful because we actually want to just unwrap the value from the step, right? And this allows us to do that. With bind, we get the unwrapping for free that's going to be passed into this function, but then we still get to operate, you know, among these steps to get the extra work done that we were doing, right? So I'm not going to write out the definition for that function yet, but I also want to talk about this return thing. Because return's sort of an interesting thing in the context of the steps that we're talking about here. Return has this type. It's going to take an A and return a step of A. And so if we look at all these steps, what we're describing here is not the work that's going to be done at runtime. In this sense, it was the work that was going to be runtime. When this function is called, we have all the arguments, we're going to do this work. This actually described a function that will return basically a step that will run all these steps internally. And that step is going to, you know, take a seed and then give us an asteroid and a new seed. So this could be used in another computation that had these steps, but that's something else. So in all of these cases, we're binding a step with a function that takes the result of the last step and produces a new step until the last part. The last part is that same kind of form, but we just wanted to return this object. But this object is not a step, right? We just have an A. We need a step of A. So return is going to allow us to do that. So return puts us back up in step space, if that makes sense. So I'm sorry if a lot of this is confusing because it is fairly abstract. But basically, when you have bind and you have return, you have something called a monad. And there's some other things about this too, like there's some laws that the implementations of these have to obey, but that's not that important. The point is there's a lot of things that can be bound like this. Like in this case, I was passing like my monad looked like this because it was a step in a computation. And so my bind would, you know, would create a new computation that would pass the state through it. So instead of writing all this, you know, I could just write this. But monads could be other things. For example, it could be a list, which kind of represents non-determinism, and I kind of don't want to get into that, so maybe that's a bad example. But it could also return, you know, maybe instead of threading a state through my computation, what if I wanted to describe a computation that could fail at any point? And so the way I would do that is instead of my step being, you know, from seed to seed, I could have my step is going to be maybe. So then each step in my computation could actually fail. So let's say I had my step 1 function would take a value and then it might produce a new value, or it might not if it failed, right? Step 2 would take, I don't know, something else. And it might produce a new value, right? The problem is these are not compatible by themselves. I can't, because I need to be able to unwrap this. And we have the same kind of case here where if I wanted to do steps, which is a function that might return a value, right? We could say it takes no arguments and it might return, you know, a value. It might look like this. So we want it to look like this. Step 1 bound with step 2. This is the nice way to write it. But if we wanted to do, if we didn't have this operator, what we would have to do is write it something like this. There's a thing here. Or we'll just do that for now. Don't worry about that. Drew says, so this monad will end up applying seed for each step. That's basically it, yeah. It will return a new computation that expects a seed and will produce a value in a seed. Yeah, the implementation of that will actually, you know, pass the seed to the different steps. So I'll get to the implementation of that in a second. Actually, you know what? Why don't I just jump back to that now? we'll go back to there. So let's actually implement bind. Or actually, I'll pull up my implementation because writing it all out is kind of annoying. But so what I have here is just one level of abstraction over what I have here. So in this case, if we go back to our first example, my step was a function, that would take a seed and produce a value in a seed. But we can actually go, one step more general, because like, what if we don't know what the seed is? We just know it's some state. So let's just call that S, right? And so now step actually generalizes over two parameters. It generates over S, which is the type of state that we have through the computation, and also does A, which is the type of value that this step is returning. It turns out this is called the state monad, and if you look up Haskell state monad, you'll find almost exactly the same thing, but some extra stuff, because that language has some extra features when you have lots of monads. Not that important. But then you can see that I have that exact same thing here, right? And so for any kind of computation where I want to pass a state through some other stuff, this is applicable. So here's my return operator, which is very simple. Return, given an x, will return a new function that takes a state and produces a value where the value you gave it is there, and then the same state, untouched, just gets passed on in that computation. Bind is more important. So we take the first step, a function that will take the value from the first step and produce the next step, and then it will return that step that this produced. Here, bind on the left takes the first step, and on the right takes this function. And what that will produce is a new function that takes some state, and it will pump that state through the left-hand side, through this step, right? And what it will get back is the value that this first step returned and the new state. And so we take that value in the new state, and then we pump it into this function here. And that function will produce, so if we just take f of x, that function will produce this next step, and then we actually run that next step with the new state. So if we looked at this kind of unrolled version here, it basically, you can see that whenever we wrote bind up here, it's basically the same as when we had tuples here and some extra seeds floating around. But now all of that's captured up within this bind. So I guess the most general way I can put this is that you would use a monad when you want to describe steps of computation that also have some extra stuff to that computation. You can think of them as almost programmable semicolons is an analogy that I quite like. So in this case, it was very, very useful to us because we had a computation where we had to do a bunch of random numbers, but we didn't want to write the seed everywhere. So we were able to wrap that up in some state and have bind take care of actually routing the seed through all of our steps. There's another place in this code where I've used that, and that's to do collisions. But I'm just actually going to remove some of this stuff. Some of my beautiful work here. I'll just show that. So this is, by the way, this is my actual init asteroids function. It basically has the same form, but things look a little bit different. Just because the functions that I'm actually calling to generate random numbers are just a little bit different. But it's basically the same thing. We're just taking all these steps here. Produce my x value, produce my y value. Yeah. That might be. Oh no, yeah, I'm generating an angle, a direction, and magnitude so that I can make my new velocity for the initial velocity for the asteroids, rotation, all that kind of stuff. But notice we never mentioned the seed here. That's pretty cool. Drew 2 says, can you explain bind a little bit more? I kind of want to, I kind of don't, because it's 9 p.m. for me, and I kind of want to get to where I'm actually making progress on the game. I'm sorry if my explanation seems really incomplete, because I know it kind of is. I think you need to kind of see a lot of examples and also try writing it yourself to really really understand it. It's kind of related to just the function composition operator like this, but it's also kind of not. In Haskell, they have this operator that means something else that's more related to this, and that's why they look similar. Yeah. But so I mean, sort of apologies for the sort of incomplete explanation, but I kind of just wanted to explain kind of what that was before I just showed you this block of code here. But it's basically just like my init asteroid function is going to take a seed and produce an asteroid and a new seed. And so I've described the steps to do that here. And the steps involve generating random numbers with the seeds and piping them through. Doru2 does says, question, all this is to keep it pure. Yeah. Yeah, this is because we need to produce, pump all those new states through all the different parts of our computation. If we had mutability, we could just go and change that state as we go along. You can kind of imagine imperative programming as having this state object there all the time. You just never reference it by name. And every time you actually make a mutable change, you have to pipe the state through the thing. Doru2 says, would you consider using a mutable rand? The answer is no, because I can't, because there is no mutability in this language. So you literally cannot describe that. That's why I wouldn't consider it. If I had mutability, that might simplify things. Anyway, I think that's really interesting, and I failed to come up with a very concise way of really describing that. Maybe someday I will, but I guess not today. In any case, it makes it so that our side computation, which is updating the seeds, doesn't get muddied up so much with what we want to do with the intent of this code, because it has to do both. The other place I use that is in collisions. I use it because I have these lists of bullets, or this list of bullet that I'm testing against all my asteroids, and so I bind some stuff here, and I use some fancy operators that I really can't describe if I can't describe the monad. So, but yeah, I do kind of want to go over the code in the asteroids module. Otherwise, though, beyond just that, so an asteroid has actually a fair amount of stuff on it compared to the other types we've seen. It has a position, which is a vector, its position on the screen. It has a velocity because it is slowly moving. It has a rotation and a rotation velocity because they are rotating, and then they each have a different speed of rotation. So that's what that's describing. They also have a size, and the size is actually an integer size, and I'm not actually using this yet, other than to calculate the radius, which actually I can get rid of the radius now. I'm going to do that really quick, and I'll get to it. It was a thing that I had before where for collisions, I would treat all asteroids as circles and just collide with a circle, and I don't do that anymore. I actually have accurate collisions now, so I'm actually going to get rid of the radius. I still need it there because I use it for the points, but I do not need it in my object. I think that's it. I think I just need to remove those two things. Yep, that worked. Oh yeah, so it has a rotation velocity, the size, which is an integer size, and the reason why I use that is because what I want to do right now, if you hit an asteroid with a bullet, it just disappears. But I want it to spawn, a couple new asteroids, and each of those asteroids I want it to be sort of one size smaller. So you can kind of think of this as like the order of the asteroid. And if the size is 1 and it's going to go to 0, it will actually not spawn any asteroids anymore. So that's what I'm going to use. To produce new asteroids from the asteroids that you've hit with bullets. Then I have this. Then I have the points, and the points is a list of vectors, and that's literally describing all these points around the object here. I need that one first of all to actually draw it. I need to have that list of points. I could actually just store the path, like the baked path here, and then use that. But I also need these points for collision detection. So I keep those. So I'm going to skip some of these functions and get back to them in a second. They're useful only for collisions, actually. But then I have, initialize. So you can initialize an asteroid. Or actually, this takes a seed and produces a list of asteroids. So all I'm going to do is I'm going to generate a random number of asteroids, in this case 2 or 3. So when I refresh it, I think I have 3. 1, 2, 3, and then this looks like 4, but it's actually this one wrapping around. So it's 3 asteroids. And then, initialize with those. The other thing that you don't have in a purely functional language is loops. So in order to do anything with loops, you instead have to use recursion. Or you have to use something else that will recurse itself, but sort of hide the iteration part of the loop. That may seem a bit confusing, but basically I have this init function, which is going to be, it's going to, take an int and a seed and produce a list of asteroids in your seed. That int is going to be like the count, sort of which asteroid we're on. So I take, the number of asteroids that we do, and I'm going to call init with that first one. So let's actually take the second case here. So the first time that's sort of evaluated, it's going to initialize, a new asteroid, just create a new asteroid. And then what it's going to do is, actually I can simplify this code. I'll do that in a second. I want to describe what this is. So we're going to create a new asteroid, and then we're going to create the rest of the asteroids by calling init again with count -1. And so that will again create a new asteroid here. So you can see how this is kind of just going to recurse in this little loop here. And then after we've hit count as 0, we're going to return empty list, right? And so this init function here will take the list of the rest of the asteroids, and we're going to combine it with the asteroid we just created. Just pop it on the end of that list. It's basically what this code is doing. So it's using recursion to create X asteroids, but really it's sort of the same thing as doing like a for loop and having like a mutable asteroid list that we add asteroids to. But that mutable list is actually sort of being stored, here, locally in all these functions on the stack as we're evaluating these functions. It's kind of fancy, but it's just the same thing as a loop, but you have to do it with recursion. It turns out recursion itself handles all the cases you would use loops or recursion in an imperative language. So it's actually a more general thing, which can make it harder to use, but you only need that one mechanism. Just kind of neat. But I'm actually going to change this code because I actually see a way that I can simplify this. If I get this right, it's going to be oops, that was supposed to be called. Yeah, so that's going to be the same. What I just did is I did fancy things. I used what's called applicative, and that's just another sort of high-level abstract thing that just allowed me to remove those names of the things that I was piping through the functions. So I'm going to take this function that's going to combine an item and a list and produce a list that contains that item. And then for the arguments of that function, I'm going to use init asteroid that's going to give me the argument, and then the rest of this init prime here, which is going to give me the rest of the asteroids. And the reason I have to do this instead of just calling that function on these two items is because remember that these aren't the actual objects themselves. This will not evaluate to an asteroid. It will evaluate to a step that will create an asteroid. So instead of just calling this function with these arguments, I have to do a little bit of syntactic tricks to make it look as close to doing that as possible, but still make sure that these are okay to be steps in a computation. So fancy things, but that makes my code simpler. If you understand how to read it, that's sort of the downside. But you get fairly used to that. So yeah, So we have this init asteroid function, and then that's this big one. We do some things just to make it a little bit nicer. So like we know that if we're going to generate an angle, it's always going to be this computation here. So later, instead of saying step with these float bounds, we just say angle when we need an angle to be generated. And I do the same thing for generating the size of an asteroid. So given its its size value here, which is going to be like that integer size that I described earlier, it's going to give us a float size. So I think I actually want to call this radius gen to make that a little more clear. Oops. Yeah, that's going to generate the radius of our asteroid given the integer size. We'll use that later here in our computation. So that's cool. Yeah, so that will actually give us an asteroid. In there, we also have things like init points, which given a radius, will generate a random count of points, either 6 to 10 points, and then it's going to use another recursive function down here to actually generate the individual points. And that's just generating these points sort of in a circle around the asteroid with some random angular stuff applied to it. It's just going to, make it less regular. And one of the things that I don't actually do is add randomness for the radius here. And I think I actually kind of want to do that. So I'm actually just going to do that now. Let's do that here. Because like now they're still pretty circular, and that one of the reasons why they stayed circular for so long when I was working on this was because for a while I was treating the collisions. I was treating these as circles to do the collisions, which is of course not correct, especially when you get like a grazing angle on this. I can sort of explain how I do the collisions now, but I want to go ahead and make these more irregular first, or less regular first, would be the way to say that in real English. So I want to take the size, right? Where's my radius? I actually want to do let's radius is radius times 0.95. We'll do a max radius. And actually, I want to make this a little more fun. So we're going to get a minimum radius and a maximum radius in this computation. So min radius, max radius. Yeah, so now we're going to add another step where in our computation where we produce the radius. I'll call this radius prime. Not as cool as Optimus Prime, but still pretty cool. And sometimes my L mode doesn't like to be that friendly with indentation. But sometimes it does. So then, yeah, make these primes, and that should do it. Yeah, so now these are a little less regular. I can do even more so. And I actually really want to kind of stretch these for now. I think that this looks bad. I don't like how this looks, so I'm probably going to change it back. But I do want to test the collisions. If I shoot see, that actually didn't look very good. Shoot a bullet. That looked very correct. For some reason, it didn't seem to look as correct when I shot this one over here. Let me shoot this one, see where it hits. See, that didn't look correct either. I'm not really sure why yet. That was definitely not correct. So it's probably a bug. So I'll have to figure that out. Dirt2 says you should compute the center of mass and make that pivot of your asteroids. I could do that. I'll put that in my mental ticket list. Make it look fancier. not watching me eat noodles is the most exciting thing, but dude's gotta eat. Duro2 says probably not supporting concave shapes for collision. So it actually does. And I'll go ahead and explain that now, but there might be a bug in how I'm doing it. I'll explain how that works. So if let me refresh this so you can actually see the asteroids again. So each of the asteroids is made up of all these points, right? That are sort of relative to a center point here. And what that means is that you can think of an asteroid as a set of triangles, where the midpoint of the asteroid is a vertex shared by all these different triangles. And you have these triangles that come out on the different edges of the asteroid, right? Does that make sense? And so then checking for collision between a bullet and an asteroid is just a matter of seeing if the bullet's position is inside any of those triangles. Topcat White Hat, looks fancy. How long have you been programming this? Since Wednesday. But I've done a lot of F# and some Haskell before, so that really helped me pick it up. Elm is fairly young as far as I know, and always changing. But yeah, so each of these asteroids, when I do collision, is I take the list of points and I take the asteroid and I map it to a list of triangles, and then I just check if any of those triangles contains the bullet's position. And actually that was in the asteroids thing here. The collision module does some stuff about like actually piping the list of bullets through all the asteroids, and then that list of bullets can change in case there was a collision, because then you have to remove that bullet from the list for the next asteroids that you do. So there's some iteration stuff that's kind of complex here that I kind of don't want to go over. It's not that exciting, but I do want to go over the collisions. The other thing that I don't handle in terms of collisions with the asteroids is that when they wrap around the screen, I don't handle collisions with that. So that's another thing I need to fix, but that's what this to-do is. So it's this lies inside function that I have. Drew2 says, do you check every triangle of every asteroid while the bullet moves? Yes. Yes, I do. I check every triangle of every asteroid against every bullet, except for the bullets in the asteroids that get removed because there was a collision. So later in the calculation, you don't check those bullets again. And we're on pretty small data sets here, so it is definitely fast enough. Because if it's going to be correct, you have to do that. And also to check if a point is inside a triangle is pretty lightweight calculation compared to what modern CPUs can handle. So this lies inside function takes a vector, which is like a point, and an asteroid, and returns a bool whether or not that vector was inside that asteroid before. Black stealth. So what this is going to do is it's going to take the asteroid and then map it to a list of triangles for that asteroid, and then it's going to check if any of those triangles contain that point, is what this code is saying. Pretty concise, and that's something that's quite nice. So then all we have to do is we need to define triangle.lies inside, and if we look at triangle, I have that function here. What this does is it calculates something called barycentric coordinates, and I actually have a feeling that I might have had a typo in here, and that's actually what's screwing up my calculations, or my collisions, so I'll actually check there first. But generally you just have a vector and a triangle, and you return a boolean. And yeah, barycentric coordinates are kind of fancy. If I do point inside triangle, I'll show you the article that I did this with. So this is from blackpawn.com. Blackpawn's actually a friend of mine from the demo scene. Really good graphics programmer. And he lists a couple techniques for testing if a point is inside a triangle. And this second one called barycentric technique is the one that I'm using because it's quite fast. It's also, if you've ever done any ray tracing, the way you do ray trace against a ray versus a triangle is you actually say, okay, well, the triangle lies in a plane, right? And so what we have to do is we have to see where the ray hits the plane and then check using barycentric coordinates if that point on that plane was inside the triangle or not. So that's actually how you do it. So this is actually a pretty good visualization of what barycentric coordinates are. So here we have a triangle with A, B, and C. As you can see, it's lighting up this triangle. Here, I'll paste this link, by the way. And so as you as the points inside the triangle, it lights up or outside. But what you see here is this U and V, and those U and V are actually describing the barycentric coordinates, right? And you can see that the length of these arrows along the edges A and B and A and C are actually what that describes. So then the point is, all you have to do is calculate those coordinates, which is just basically some dot products and some stuff. And then at the end, just check if your barycentric coordinates are within certain ranges, and that will give you whether or not the point was inside or outside the triangle. So that's exactly what I'm doing here. And I just want to check my math against this one more time, and then I'll probably find a second source that also goes over this, because I do kind of have a feeling that this is where I'm messing up. We'll see. I have another idea of where it might be. He also does a little optimization here where he takes, instead of calculating the denominator of these fractions that'll calculate the U and V, he does the inverse denominator, which is where you take 1 divided by this and then multiply it here and here. That's an old speed optimization that I don't bother doing because I think it's makes the code's intent a little less clear. Is this, assuming correct order of operations, this will be correct, and I know that Elm actually has that, so that looks okay. So it looks like my math here is correct, at least according to this source. So I want to go ahead and check the Wikipedia entry for this. I think because it's going to be written in much more mathy terms, it's going to be a little less friendly for me to read, but yeah, this is basically saying the same thing here. Application determining location with respect to triangles to see whether or not you're in there. If a point lies in the interior of the triangle, all the barycentric coordinates lie in the open interval 0 and 1. And then we have another couple special cases there. So what was this? Daru was saying, are you sure about operator precedence here? And am I sure that that's correct? So it should be correct because double AND here can only take booleans. I don't believe you have any implicit value conversion except for constants in this language. So this would have to resolve correctly for the types to match up. I'd imagine. So I think that that's actually going to be okay. Yeah, Moe000 saying if not, it would be if bool is less than integer. That couldn't happen. Because the real thing here is that we just need to know that these these have lower precedence than these operators, these infix operators. And if that's the case, then it will work out. And again, I think if that were going to be the issue and we needed parens, I think the types wouldn't work out. But worth checking, worth thinking about it again. So I want more of an algorithmic way of writing this. Google that. Here we have ray tracing rendering a triangle with barycentric coordinates. That's again what I was describing. Let's see if it gives us, yeah, pseudocode. That'll do. Basically, I have the same thing there as well. Now I have some cross products, which I believe was one of these. Unfortunately, it's not written as sort of as the other one. Plane's normal, finding P. Plane umbrella, D, T, which will give us the point on the plane, which is this. That's P. Now we do the inside-outside test here. So I don't feel like sitting there sifting through that code and reformulating it until it kind of matches the form that we have. I honestly don't think that this is where it's wrong. Yeah. Black Stealth is saying it's talking about asking how long I've been doing the Asteroids clone. Also since Wednesday. So I learned Elm with this project, or I am learning Elm with this project. Let's say that. Okay. So then, assuming that that's correct, then this is correct, except for the wrapping part, but we're not going to worry about that right now. So then all we need to do is make sure that the triangles that we produce for a given asteroid are correct. So the first thing I do to generate those triangles is I take the points inside the asteroid and I transform them to absolute points. And what do I mean by that? So the points per asteroid are stored relative to the center of the asteroid. But the asteroid has not only movement, but also rotation. And so what we need to do is we need to take these points that are relative to the center and actually project them basically on the screen, which is going to be the same space that the bullet's position is going to be in. And so we're going to represent all of our triangles in that space. So to do that, I take all the points and I call this absolute points function on the asteroid, and it will give me a list of the absolute points that make up the asteroid. And then what I do is I form the triangles from that. So I actually want to look at this absolute points function here. Excuse me, because I have a feeling that might be where the bug is. Yeah, that's very wrong, seems to be the consensus here. So what I want to do is I actually want to look at my drawing function, because this does a couple things. In particular, I actually think this is what the problem is. And let me do something here. Just see if this fixes it. And if it does, then I understand what's going on. That's that an asteroid's easy to blast away. I'll explain what's going on if this works. Otherwise, it's that looked really good. Okay, so I think we just found the bug. So my bullets have relative velocity. So if my ship's moving backwards really fast like that, then okay. So I think we got this. Boom. Yeah, looks like we got it. So let me explain what's going on here. So I'll go ahead and fix this, and then I'll fix the code properly in a sec. So when I draw these, let's look at the drawing code. When I draw these, I basically take all the points and I put those into a polygon, and that just gives me a shape, right? And then I make a group out of the shape filled in with black, and then another object where it's going to be the shape but outlined. So these are two forms. You can't specify both on one thing, unfortunately, so I just specify two and then group them. So I have the filled black first and then the outlined version of the same points. And so then what I do is I take that group and I rotate it using the collages rotate function. And the reason why I do that is because I figure, let's just give Elm's rendering stuff the points and then have it rotate and move everything because it might have a faster way of doing that than what I'm doing. But what happened here then, so we rotate the point and then we move it relative to the position. And then that's where we draw the asteroid. Fine, that's pretty easy. And then if we look at our absolute points function here, it does the exact same thing. So we're taking all the points and we're going to rotate them around with the asteroid's rotation, and then we're going to add the position, and then we get the points. So Daru in chat has already got it. The issue here is that if we look at my vector thing, we have the rotate function. So does this rotate the angle clockwise or counterclockwise? And frankly, I don't remember. It's very easy to make a rotation function that'll do either. I think it does it clockwise because of the way I've written this with the ship. I believe I tried to make it so that, you know, positive angle would do it clockwise. So like as I'm holding right, then it would rotate the ship. But I may have gotten it wrong with the flipped coordinate system, so it could be wrong. But the point here is that my rotation function rotates differently than the collage's rotate function. So that's going to be the thing. So that's why when I fixed it, I could just take negative rotation here for generating the absolute points. The way I'm going to properly fix it is instead of using the collages rotate and the collages move, I think I'm actually going to map the points to the absolute points and then build my polygons out of that, so that both the collision detection stuff and the drawing both use this same function here, so we know that that's going to be the same logic. So that was the issue. We had the collision detection stuff thought that the asteroid was rotating one way. The drawing stuff thought it was rotating the other way, and that didn't work. So if we do that should do it. And that's the cool part about using these functional languages. Is just like everything gets so composable and everything gets so nice that it's so easy to do those kind of changes. That should do it, and now this should work. Boom. Oh, nice. That actually looked great. How it went just past one vector or one vertex and hit the other one. That was pretty cool. This one might not hit actually because it's wrapping around the screen and I haven't implemented that correctly. So depends on whether or not the asteroid was actually over here being wrapped over here or over here being wrapped over here. In that case, it ended up working out. But that was pretty cool. So now we have fixed the collisions. I also made the collision code a little bit simpler earlier, so that was nice. And yeah, pretty cool. So now I'm wondering if there's, I can remove some of this stuff that I imported from Collage. I don't think I use that anymore, so I'm just gonna remove that. Oh, that looks pretty good. I'm gonna go ahead and push this. So one of the other reasons why I do my collision this way, first of all, it's a way that I just understand mathematically, even though I don't know how to, you know, calculate the barycentric coordinates exactly. I know that when I have them, I know how to do this algorithm. The other reason is because it's pretty easy to see if two triangles overlap. And I'm going to use that for collision with the asteroids in the ship later. For now, I'm not going to worry about that. Because I don't feel like implementing that part of this yet. But that's going to be the case. Whatev.001 says need to add dstore to gitignore. I can, but I don't really like having platform-specific stuff in the gitignore, and I just don't find it that annoying that I have to go around that whenever I open my Git thing. I know you've mentioned that before on my N64 stream, but it just doesn't bug me enough. So I'm actually going to make these asteroids a little more regular again. Actually, I want to see what happens if I generate a lot more points. Just to see what that looks like. No, I'm just playing around. So now we get really funky asteroids like this, and that's actually pretty cool. Let's bump up the minimum number of points. I think that'll look nice. So now we got some pretty crazy asteroids. And that was correct. Looking pretty good. Boom. Oh, this looks great. That's kind of the thing about this, is that even if I'm doing asteroids like a really simple game, I want to do at least these kind of things correctly. First of all, just because it's more fun to actually sit down and work through those kind of problems. But second of all, because I feel like if you cut corners to make a problem like this simpler when you're learning a language, I think you kind of miss out. I think you have to, like, if you're going to learn a language with a simple project like this, you still need to do a certain amount of work before you really feel like, oh yeah, I'm getting this. Duru2 says, now you see how they don't rotate around the center of mass. Yeah, I think I'm not going to worry about it for now, at least. If I did center of mass, then I'm not really sure how hard it would be to calculate, but I'm just going to let it slide. But another thing that we see actually is that it was the speed wasn't a problem. So that was pretty cool, because I definitely bumped up the number of vertices by potentially quite a lot. Maybe it becomes a problem when we have a lot of smaller asteroids, but we'll see. So now I want to make them a little more regular by reducing how much randomness we have in the radius, I think is what I want to do there. And I'll make that even a little less. So this to me actually looks pretty good. I think that this is kind of the asteroid look I was going for. Moveaway00 says, need to spawn further away from the player. So that's another thing, is that we can try to spawn asteroids that aren't overlapping with the player. I think what I wanted to do was actually have different game states, where you're kind of in game or you're out of game. And so the out of game state, it wouldn't really matter where the asteroids are, and you would just start playing where your ship sort of wasn't in the middle of the screen. An alternative could be also to just draw the ship on top, and then to have, like, when you start the game, you have like a period of time where like the ship is flashing or something, like you're basically invincible and you can run through asteroids. Actually, I think now that I think about it, the latter is what I'll probably do, at least first, because I don't have to implement the game states until later. I can kind of defer that problem and solve the problem at hand with something that's a little more intuitive. So what I'm going to do down here is I'm going to go into my view, and I'm just going to draw the player after everything else, or at least after the asteroids. So that's all I had to do that. Now the player's drawn on top of here. That looks pretty all right. Was that okay? Or was I just not paying attention? Looked like that was wrong, but no, that was definitely correct. Actually, I think before I implement this player flashing thing, I think I'm actually gonna take a little quick break. So yeah, see you guys in 5. All right. Okay. Movie 000, couldn't you just modify init asteroid to not spawn a small box around the center? Yeah, I could also do that. I'll probably do both, actually. Because if I had the concept of lives, for example, I still want to have that, like, intermediate time where you are invincible. Because you're gonna run into the same case, too, then, when you respawn. That, you know, an asteroid might be in the middle, you need to get out of the way. Another thing I'm noticing really quick here that'll be super easy to fix is now that I'm drawing the ship above here, we can see that if they intersect, you can see that my ship is not opaque, and I kind of want it to be. So I'm gonna go ahead and fix that really quick. How do I do this in? I called it form. I'll do that in here too. Let's do it. Oh, I need filled here. Okay. So now our ship is opaque. Nice. So now let's go ahead and try to get our asteroids not to spawn in sort of a middle point here. I'm not really sure how I'm going to do that yet. I'm going to do a safe zone here. So this is my bounds module, just like the width and the height of the canvas, which I could also take from like the web page if I want to make it full screen, but I'm not doing that. It's kind of by choice. Safe zone is going to be vector. Safe zone size is going to be floats. I don't know, we can make it like 100 by 100. Okay, so now we have a vector that just describes our safe zone in here somewhere. Movie 000, so this should just be get a smaller random range, and if it's greater than the start of your safe zone, add the width of the safe zone to the spawn chord. Yeah, that would work. Should work in both directions as well. Just kind of think about how to do that then. You know what else I could do is I could not use a smaller random range. And if it's inside that safe zone, I can just move it. And that's fine, because I can just wrap that resulting position. I think that might be a little bit simpler. I'm going to do that, actually. To do that, we also need to know the size of the asteroid to know how much to move it. So I think I'm going to do all that here. Seeing that will bias point towards points just outside the safe zone, though, right? Yeah, it could, because some of our random range would then be mapped to the outside of the safe zone. So maybe we can get a slightly better distribution if we don't do it that way, but I have a feeling that it's not going to make much of a difference. In fact, what I think I'm going to do is I'm going to not have this as bounds, so not have it be a square, but have it be a radius. And I'll just move it radially. I think that's how I'll do it. Ohio, Yuki. Good to see you again. I think also I have this min and max radius here that I pass in to init points. I calculate in init points. I'm actually going to pass that in so that we can use the max radius to move the asteroids out of the way. I think that's what I'll do. Crazy indentation sometimes. But that's nice. That's pretty nice. So then that goes here as well. Yeah, I think we didn't do it this way where we just like kind of move it out of the box. Yeah, because I guess we would subtract the bounds of that box when we're doing the minimum and max. And then depending on if we were greater than or equal to the origin, we would add or remove that kind of thing. I think this will be all right. I just think this will be a little bit simpler, even though we get the slight bias. Ohio Yuki, I started reading the book so I can learn Rust, but I don't know how long I'll stick to it. I tend to jump with languages. Yeah, me too. If you haven't noticed, I'm doing Elm right now. I think actually though, after this project, I probably won't touch Elm for a long time. Just because I'm not that interested in doing web stuff in general. And I feel like most of the time when I need like a front end framework, I don't think Elm is the right tool for the job. But it's a really cool thing. And I'm enjoying doing this project in it. I think if I were to do another like game project in a functional language, I would do something with probably Haskell. Then I would just need some kind of drawing library. Yeah, okay, so we were going to, here we have the radius. And then we had min radius and max radius here. Fix all my indentation here. Where is that? Ah, here. So then this is basically the same now. Lovely. Oh, I love when collision stuff works right. That's so satisfying as a programmer. Yeah. Let's just not worry about the names for a second. Do I have bounds here? Yeah. I guess we'll do. We could push it in the same direction. I don't think I have a normalize function here, but I can add one. I'll add it here. Or do I have div? I'll make div. Makes it even nicer. Oh yeah, Mul was doing a float in a vector. I might change that actually. For now, but for now we'll just do div as vector to vector, even though it's not symmetrical. For now. You'll notice too, like add and sub and all those look the same. So I might abstract that as well. But I'll do that in a second. So this is actually, oh wait, div in that case would also be a float. So that's kind of ironic. We'll take this way. I need this. So we'll take div vector by the length of the vector. There we go. So in that case, when our point is not in the safe zone, then we're going to let me do something. And actually, you know what? We can just do the dot product every time. Why not? Then we can just say position is That's nice. Cool. And then why don't we just do that here? Nice. Oops. So actually, we can do this. Aha! Oh, wait, yeah, because we need the vector there. Cannot find variable normalize. Oh yeah, I didn't export it from here. Fancy. So I don't think that quite worked because our safe zone didn't take into account the size of the asteroids. We can do that here. Use the same let block. Done. There we go. Now we're safe. For now. Still so satisfying watching the collisions. Oh, just got it at the end there. Nice. So I really want this random seed now. What do we do here? Is the safe zone basically all we did here? I think so. And made the player opaque. Made ship opaque. What was I gonna do? Totally lost my train of thought. Yeah, proper random state at the beginning. So this, I'm not entirely sure how to do that actually, because what we really want to do is, I'm trying to say, we want to have the current time as sort of an argument to our initial state is actually what would be the best thing. So what I want to do is I want to take the current time like on the system and use that as our initial seed for our everything. But to do that, we would need, in this init function, we would need to get the current time. And I'm fairly certain that the only real way to do that is either to redefine program, which I could probably do, but I don't want to do that. I think the only other really way to do that is to send a command to give us time. Or yeah, so I'm actually looking at an outdated package here. Yeah, to run a task. So this is where we start hitting parts of Elm where I'm just like, I don't know how to do that yet. So I'll have to dig a little bit. Another thing that we could do is we could so like these are my subscriptions normally as I listen for the differences between the current time and the last time. We could also do one dummy frame if we wanted to. So the first frame is just going to take the actual time. So in this case, it was requests animation frame, I think it was called. It's animation frame. That was helpful. Here we go. Yeah, so times. So we could subscribe to times for the first frame, and then what it will do is it will send us a message that will contain the first time, basically. And then we can use that to sort of seed the rest of our game. I think that's kind of how we have to do it anyway, because if we're going to have to... we're going to have, anyway, if we want to get the time, like even through the command mechanism, I think we have to send it out here. So we have an initial state, at least, without a random seed anyway. So I think just having that one sort of dummy frame is probably the simplest way we can do that. So that means our model changes a bit in terms of the type, because it means it's actually going to be a couple different things. So what I think I'm going to do, I'm going to call this game state. And our model is going to be a couple options, a couple different things. I'm pretty sure we want union types here. So we're going to call this, we want to have like an init state, or I don't know if I want to call it game state. But that's not too bad, actually. But then in our message, we want to add another message type as well. Oh, is that how you align that in there? When you do that? Yeah, looks a bit nicer. So here's the other thing I'm worried about, is that if we have init, right? We'll use time for the first one. But see that now we have two constructors in here that are called init, so that'll be ambiguous. But I think we'll take init from the message and rename this. I think we can call this initializing. So our program is either initializing or it's gaming. We can call it uninitialized. We either have an uninitialized model or we have a game model with a game state. I think that that's okay. So now actually the init function will be a little bit simpler. This is going to be there's our initial state. And now we have a couple things. So the only thing I really don't like about this now is that we have to basically handle most messages depending on, or no matter what our model is. I think here's what I'm going to do though. I think I'm going to case model of, I misspelled uninitialized. So the model is uninitialized. We're basically going to create a new model. Why is that out there now? Oh, that makes sense. Okay. Also, we'll do this. for reasons that will make sense. I actually want to tab that one out. Yeah, so we'll keep this command none at the end there. But the model's uninitialized. Then what we actually do is we case message. And in this case, we either get init with a time value, in which case that's when we'll actually do this. Yeah, that makes sense actually. Okay. Right, so now we have the time, which then we can actually convert to a seed here. So I'll just do that really quick. We can just go with millisecond. Oh no, that's the units. So let's do we'll do King Darrow. Been looking into Elm a lot as of recent, super interesting stuff. Yeah, it's been fun to play with. It's time, and then we'll do to integer. Cool. So that'll take care of our random seed. But then, what if the message was anything other than init in this case? I don't know why it's not indenting that correctly. That's fairly annoying. Okay, so if it's not that message, then we're just going to return the model as it was. King Darrow, what editor are you using? Looks like Emacs or Vim. I couldn't do the syntax too much. This is Emacs with Elm mode. So that's basically everything. If we get an uninitialized model, then we only care about the init message. Everything else we're going to throw away. I think that's all right. So the other thing we'll have is down in here. We're going to have a game model with a game state down here. It should be back here, I think. Oh, right now my indentation's being a pain, but we'll be all right. So otherwise, if it's a game with game state, then we're going to do the logic we had previously. Right? Really special indentation right now. Let's let that slide. Actually, I want to put this here. Not a personal fan of the alignment standard either, is King Darrow. So actually, the alignment standard I generally like, but the Emacs mode is kind of jank in my case. King Darrow says, in procedural language, you generally have statements and blocks. There's basically just lists of statements. Functional languages like Elm, functions can only have one statement. Yeah, that is the case. If you were to define a function that called two functions, well, so in Elm, the way you would do that is like, well, you could do it in like a let block. Like here, I call two functions because I just have these definitions here. You could also bind two functions together. That would also give you the sequentiality. You can use monads, so then you actually bind and you create the steps to actually call the functions in order. So there's actually a lot of different ways to get sequential computation. But yeah, it all ends up being one expression. So like in this case, this let is one expression that has all these sub-expressions that get bound to names in this order. But then yeah, this let in is one expression that will return this value, even though it's doing all these intermediate computations. So there's a lot of places where it will look imperative, and that's no accident. If you're in Haskell, you could also use do notation, which looks really like imperative code. Okay, but now basically every time where I would say model, it now says game state. And there's another thing that I have to do really quick. I just remembered. So here, we just return models in that case. So here, we don't just return this object anymore. In fact, oh, that might be why it screwed up all my indentation, because I had that extra paren. That's kind of funny. That's probably the whole reason it did that, actually. Okay. So what I'm going to do here now is, instead of just returning the object, that's just going to return a game state object, but we need to return a model. So we have to say game here, where this is the argument. Because we're going to return a new game model with this game state, this initial game state. Otherwise here, we take this game state and then we map it to basically a new game state. Or we also need to wrap that up. And I really want that to be there. I might just live with it though. What the editor gives me. No, I won't. Indecisive about indentation. So in that case, it should almost work. What didn't it like about this? Oh, because type alias, this is going to be type. To integer couldn't find. Oh yeah, because we have to do like floor, ceiling, or round. So I'm just going to do floor. Makes you specify the rounding that way. First, second branch of this case produce different types of values. The first branch has model, and the other one had yeah, the game state. I think that was here that it was doing that. Yeah, and now these don't quite matter. This one's going to be fine because we're going to need to do some changes there. This, now that we have a model, we actually need to match on that. Model of. So when it's uninitialized, we could just say like loading or something. Like what's do this here. Let's do some text. Do I? Yeah, okay, so I do have HTML. I think this will just work then if I do there we go. In the other case, we're going to have a game with a game state. And that's where we want to do this stuff. And convert that to an HTML element. Dip that there. Okay. And I misspelled uninitialized again. Yes, now I have text is ambiguous because I have HTML.txt and collage.txt. What from collage am I actually using? It's probably collage and rect and filled, I think. I'll just import those specifically. So now it's telling me that all the messages are not covered, and that actually makes sense. Because in this case, we don't handle the init message. The other thing you'll notice here is that we're using this game constructor all the time when we're doing this. Actually, here I'll just return model. But otherwise, we could have put that game constructor out here and just return game states in here. But I think this is probably fine. Not going to worry about it too much. Yeah, now I have a loading message. That's actually pretty cool. So then the reason why this isn't actually starting now is because we never subscribed to anything that would actually give us the time. So what we need to do is we need to take the model in here, and depending on whether or not the model was uninitialized or not, we're going to either subscribe to something that will give us the time for the first frame, or subscribe to the things that will give us deltas between the times. So case model of, one second, I'm going to change the music. Uninitialized is going to give us, we'll do, I believe it's called times. What's the animation frame? Yeah, we'll do times. And we'll just do init, because the message will just take that thing directly. So when we say the name of one of those options like that, that's actually a function that will take in whatever argument it would need, in this case the time value, and then produce an object of that type. And since times is expecting a function to basically do that, we should be good. So that's all we need to write in that case. And then otherwise, if we have a game with a game state, or actually the game state doesn't matter in this case, because we're not actually using it for anything. Then we have that. And I misspelled uninitialized again. So it looks like this works. That's pretty sick. Seems strange that we're only ever getting 2 asteroids though. Wonder why that is. I'm also going to change the loading text to say initializing. Oh, Yuki are using tabs, not spaces. Oh, there's 3 asteroids. So I guess it was just, we were unlucky. Yeah, but cool, that means it works. I may refactor some of this later, but for now it's okay. It's a bit roundabout how we kind of had to do that, but it does work. Still satisfied by those collisions. Oh, nice. Lots of bullets. They all died before they hit that thing. Pop. Okay, cool. Holy nuts, it's 10:30. I did not expect that. I wonder if there's anything I can do quick. I should probably head out. If there's anything I could do in like 15 minutes, then I kind of want to do it. I don't want to do ship collisions yet. I could do the asteroids breaking apart maybe. But I did actually start working on that. Didn't I? Yeah, because this is a... Oh, sorry. Yeah, because these are lists now. Here. So what I think I'm going to do is in my asteroids module, I want to make a split function that will split two asteroids, or split an asteroid into two, right? So the way I'm going to do that is, yeah, basically if our bullet point was inside the asteroid, we're going to remove the bullet, and can't really explain how that works with in short period of, with not that much time. Then we're also going to create a list of new asteroids from the previous one. So we'll do split asteroid. And then we'll just need to do our split function. We'll do that here. Split has the type asteroid, which will turn into a list of asteroids. And actually, we're going to need random here. I think that's why I decided I didn't want to do that right away. So I'll actually take an asteroid to seed. We'll turn a list of asteroids and a new seed. Yes. Yeah. We really just need to call init asteroid, but with a different size value. So I think the way we do that is we have this also take rename some things here. Okay. This size here. We'll do min size and max size. I will also, that'll propagate through here. Can go as a step. Oh yeah, it's just reading the, yep, random numbers. That's 4 and 5 when it's initializing these. Okay. Cool. And so now we can call init asteroid later with a minimum size and a maximum size. That's pretty nice. You know what, actually though, I think I kind of want to just have them all be the same size initially, just to make this a little bit simpler. Because when, no, actually that should be fine, because when they break apart, I'll just use the same value as min and max. That'll be okay. That'll be okay. So split is actually going to be pretty simple. It's just going to be Just a couple in asteroids. I think boom. There's a bit of a problem here though. And that's that we don't actually have a seed here. So I'm not really sure how I'm going to handle that yet. The other thing also is that we need the size. So actually, we also have the case where it won't split anymore. So we'll do that as well. So we'll do that size is size -1. If size is greater than 0, then we'll create the new asteroid. Otherwise, empty list. Create the 2 new asteroids, otherwise the empty list. Right, we need to return that. I may have had this wrong here. Yeah, I know what I did wrong here. I can't actually do it like this, but that's fine. Or no, because yeah, that has to do with argument order, so I can't use duplicative here. I should be able to do you know, I'll just write it out like this. Collect my thoughts that way. Yep. Of course, this is we can even do that. Oh no, we can't do that. Dang. Let's do asteroid prime. Whoops. They're saying that init prime doesn't have the right type. Not sure why, actually. No. What are these? Stealth Ferris makes emulators in Elm. Not today. I don't think I would make an emulator in Elm, but I have thought a lot about doing emulators in functional languages, and I've also thought a lot about making a language that's functional to do emulators in. Thought a lot about that. Thought a lot about that. Huh. By the way, that's pretty cute. Didn't really help us with the error, but stuff I can get rid of. I'm not really sure why this isn't working, actually. I'm not sure why I messed this up. It listed be int. Where did it get that? This is correct. This is what it should be. Oh. Huh. Yeah, that makes sense. Okay, and now we're running into the case where this actually won't work because it needs the random seed. That's a bit unfortunate. I can cheat and just make up a random seed there just to test that the rest of everything works. I think I'll do that actually, just to test. What's that called? Initial seed. Okay, so yeah, so that actually seems to work. I mean, the random seed that we use there is just borked, so we'll get the same patterns over and over again. But we actually have the asteroid being split into different asteroids, and at some point they should stop splitting. And that's actually quite cool. Now we start getting a lot of these things. The other thing I think also is that they kind of spawn at random points when we split. So that wasn't correct. Yeah, see, they just kind of spawn randomly. In fact, they all spawn here because it's all the same random seed. Well, here's what I'm going to do. I'm going to put this back. I'm going to go back to my asteroids thing. Rid of this. Leave it here, but add a to-do here. Other thing I want to do is in an asteroid, I want to do a to-do here as well. Make smaller asteroids move faster. Because that'll be cooler. So the next thing I have to do is I have to figure out how to sort of rework this code to also pump the random seed through there. And I just don't think I'll do that today. It's getting kind of late, so yeah, I think I'll call it quits for now. So if you guys have any questions, I can take those before I go. By the way, I'll post the repo link again. You guys are curious. Sixu says, are you going to upload these to YouTube as well? I planned on it. I did record it. So I'll do that as I go. I'll probably just let it upload overnight and then tomorrow publish it and do the annotations and everything. So it'll probably be out tomorrow. Yeah, I was going to upload this to YouTube. Hi, Yuki. Thanks for streaming. Yeah, no problem. Sixu also said thanks for the stream. Again, no problem. Thanks for watching. Any other questions or anything? Black Stealth, this isn't related to Elm, but what advice would you have to writing to memory and accessing the instructions from the stored code in memory for an emulator? I'm not really sure what you're asking exactly. Like how to do that dispatch loop, or how to like structure how those pieces fit together? Because the answer then is still it depends, but I don't really understand what specifically you're asking. Need to drink more water. Space Cats, another one not related to Elm. Any good resources on graphics programming for emulators? I've always found that the graphics and controls are what trip me up the most. So it depends on what kind of emulator you're doing in terms of graphics. Like, if it's going to be like an older system that's doing like pixel art, then you typically need a library that'll give you like just a frame buffer. You can make that yourself, but it's going to be a lot of like low-level OS specific work. There's a couple libraries that already do that. Like the biggest one would probably be SDL or SDL2. Will give you that. But then it's just a matter of plotting pixels, so it really depends on kind of what your emulator's doing. I mean, I hate to give that broad of an answer, but it really does depend, because then there's like emulators like Dreamcast or N64 that are going to do some rasterization. And then you can still do that with a pixel buffer, and you'll want to do that if you want the thing to be actually like pixel perfect, but probably going to be too slow. Black Stealth, like how would you go at it? Also, will I be using Glium for Rostendo or SDL2 plus Glium? I think I'll probably just use raw GL bindings. So neither. GL-RS is probably what I use. Because Glium provides like nice safe interfaces, but it's going to be easier for me to not learn those at first probably, and I don't see much benefit of doing that. But that's just because I'm pretty comfortable with GL. Maybe later, not GFX-RS. I hadn't seen GFX-RS, but I don't think it has what I'm after. Because the thing is that I don't really care about the safety, and I'm going to be using OpenGL, so I might as well just use GLRS. That was my plan anyway. But your other question about writing to memory and accessing the instructions from stored code in memory. I mean, you usually just have a loop, especially for older systems, that's just going to run like the CPU is kind of the driver. And it just runs in a loop where like the first thing it does, it goes and fetches an instruction, and that just hits the memory bus. So it could like fetch an instruction from an address that could be a value from, you know, one of your peripherals, one of the registers, but that's the program's fault for loading that address. But that's basically it. Like it will just go and do that, and then you just have a big old switch statement that switches on the instructions and does different things. Some of those things will write back to memory, that kind of thing. So you like your read and write functions will typically abstract the memory mapping. So when you read from a particular address, you know, that might go to one of your peripherals or it might go to RAM or something. It's up to how you do the mapping. But that, I mean, that's basically it, mostly. In Rust, it's a bit harder because you might have, like the dependencies can get a bit tough. Like still saying, so an interpreter if you use a switch statement. Yeah, I mean, that'll work. Topcat Whitecat, thanks for the stream. Thanks for watching. Rusher Room, thanks for the stream. Elm looks interesting. Again, thanks for watching. Elm is interesting. I hope to actually finish this project pretty soon. Like I got some other stuff that I really should be working on instead. But I just really wanted to try Elm. So I hope to get this project finished in the next couple days. I might stream some of it later as well, but I probably won't describe as much stuff because I really want to get it done. When I figure out like how this certain state is going to pass through this collision logic, that'll solve a lot of problems, because later when I add like explosion particles, what I want to actually do is take each asteroid as it explodes and take all of its edges and make line particles that will then sort of diverge. I want to do that. So I also need to be able to pass that state through here as well. It's going to be kind of annoying, I think, but I'll figure it out. So it looks like that's about all the questions. Thanks again, guys, for watching. I'll have this up on YouTube when I do. And yeah, see you around.